First question, by completing the square, rewrite this equation into the standard form of an ellipse. Okay, so I go to complete the square. So I'm just going to move this to another page so I have some room. All right, so I think I'm just going to multiply every term on both sides of this equation by 5. I really dislike the fraction, right? So I'm just going to multiply everything by 5, so I end up with x squared minus 20x plus 6y, oops, 5y squared. I was getting ahead of myself. 5y squared plus 30y minus 5 equals still 0, right? Because 0 times 5 is still 0. So I just multiplied everything through by 5 to get rid of the fraction. All right, so completing the square, I've already got my x's sort of bundled together and my y's bundled together. I'm going to move my 5 to the other side of the equation. So you kind of want to group your x's, group your y's, put anything that's not an x or a y on the other side. All right, so now to complete the square, I have to add something, well, plus blah, right? What do I add to complete the square? And then for the y's, I'm going to factor out a 5. So it's going to be y squared plus 6y plus something equals 5. And if I added stuff to the left side of an equation, you have to also add it to the right side. So whatever I added over there on the left, I have to add on the right. All right, what do I add to x squared minus 20x to make a perfect square? 10 squared, 100, yeah. So there's a really fast way to figure that out, and I'll tell you in a second, but the goal is to add something in this box here so that x squared minus 20x plus that thing can factor to something squared, the difference of two squares or the sum of two squares, right? So this thing would factor to x plus or minus something squared. So you have to like sort of be familiar with how to square stuff. And I have this little, I say it's a rhyme, but it doesn't rhyme at all. When I square a binomial, like let's say I want to do x plus 3 squared, you do square the first, square the last, take the product of the two, 3x, and double it. Square the first, square the last, take the product, and double it. Okay. So if the double the product of x and whatever number goes here is 20, what number has to go here? 10, right? If you take 10x and double it, you get 20x, right? And then when you square the 10, you get the 100. Right? So a quick way to come up with the 100 is you take the coefficient of the x term, divide it in 2, and then square it. So b over 2 squared. So you take half of 20, which is 10, square it, you get 100. Okay, so come over to the y's. So quickly, what I would put here would be 9. Take half of the 6, square it, and you get 9. Okay, and then that's going to factor to y plus 3 squared. All right, now I have to figure out what to add on this side. I have to add the same thing you added on the left. So I'm going to put a 100 here. And then this one's tricky. It's 45, yeah, because I put a 9 here, but it's really 5 times 9 when you distribute that 5. So it's really a 45. So the right side of my equation is now 150. All right, so I'm almost done. It's not quite the standard form of an ellipse, because an ellipse, it's got these denominators, right? The coefficients on your 2 squared factors are 1, and it's got denominators. And your right-hand side of the equation is supposed to be 1 also. Okay, so if the right-hand side of my equation is supposed to be 1, I'm going to divide everything by 150. Okay, so I have x minus 10 squared over 150 plus 5 and 150 reduces. 5 goes into 5 once, and it goes into 150 30 times. So I have y plus 3 squared over 30 equals 1. So now this is in the standard form of an ellipse, and I can say that the center, well, the center of my ellipse is at 10, negative 3, right? But what they asked me for were the a and the b. Find the center of the ellipse, oh, and the values of a and b. Okay, so my center is going to be at 10, 3. You get that from these numbers here, 10, oh, and negative 3. Mistake. So because the standard form has x minus h, you ignore the sign here, right? When it said x minus 10, h is the only value that you're interested in. The minus sign is part of the equation. And when it says x plus 3, you would look at that as x minus negative 3 because the minus is part of the equation and the negative 3 is the k value. So that's why it's 10, negative 3. And then a and b is just the square root of these denominators. So a would be radical 150 and b would be radical 30. Yeah. Yes, to complete. Yeah. Yeah. Your denominator would just be a fraction, like, or a decimal. So, like, yeah, if this was 5 over 22, right, your denominator would be 22/5. Yeah. Okay, a fuel-efficient way to travel from Earth to Mars is to follow a semi-elliptical orbit known as a Hohmann transfer orbit. Spacecraft leaves the Earth at the point on the ellipse closest to the Sun. Okay. Arrives at Mars at the point on the ellipse farthest from the Sun. So this thing in blue is the Hohmann transfer orbit. Okay, got it. Let RE be the radius of the Earth. Okay, so E stands for Earth, radius of the Earth. RM be the radius of the Mars orbit, and let 2A and 2B be the respective lengths of the horizontal and vertical axes of the ellipse. Okay, so this distance is 2A, this distance is 2B. Orienting the ellipse as shown in the figure with the Sun at the origin, find a formula for this orbit in terms of the Earth's radius, Mars' radius, A and B. Oh, just B. Okay, so we're given a set of parametric equations. 2 cosine t, x is 2 cosine t, and y is 3 plus sine t, graphing t from 0 to 2 pi. So I tend to just eliminate the parameter here instead of remembering a whole nother set of rules of like when is this thing an ellipse, a hyperbola, a parabola, etc. I like to eliminate the parameter and just look at it in terms of this sheet of how to classify. All right, so I know that x squared, sorry, Pythagorean identity says that cosine squared plus sine squared equals 1. Okay, so instead I'm going to say, well, what's cosine? If x is 2 cosine t, I'm going to solve for the cosine of t. Cosine of t is x over 2. And then y is 3 plus sine t. So that means that sine of t is y minus 3. Solve for the cosine and the sine, and then replace them in the Pythagorean identity. So we're going to have, x squared over 4 plus y minus 3 squared over 1 equals 1. And then I can look at that thing and classify it from this document. And it's an ellipse because it's got the plus instead of a minus. It's an ellipse. Okay, so then we're supposed to find its center. What's the center of that ellipse? Zero, 3. Good. And then I'm supposed to find the lengths of the major and minor axes. So the length of the long axis and the short axis. So if I look at this guy, my information for an ellipse, it looks like if A has to be bigger than B, right? It looks like this guy, right? Because it's the bigger denominator comes first, is under the x. Okay, so my center's at HK. My vertices, A is this means it has a horizontal major axis. Okay, so that's all I need to know. Horizontal major axis, A is 2 and B is 1. So my horizontal major axis means I could sketch a graph of this thing. Center is at 0, 3. Horizontal major axis, A is 2, so I go right 2 and left 2. And then my vertical axis, I use the fact that B is 1, so I go up 1 and down 1, and there's my ellipse. It's a terrible drawing, but you get the idea. The square roots of the denominators. Yep. So the number under x, where'd it go? Yeah, the number under x when it's bigger is the A. So basically A is the square root of the larger denominator, regardless of where it shows up. A is the square root of the larger denominator. Okay, and then let's look at number 2 here. I'll do this on another page. Okay, so what is that? Ellipse or hyperbola? It's an ellipse because it's got a plus, right? Hyperbolas have a subtraction sign in between there. So this is an ellipse. And its center is at -8, 7. And my so is this a horizontal or a vertical major axis? Vertical, because the larger denominator is underneath y. Right, so this is a vertical major axis. Okay. And it's length of 2. Half of its length is 2. And then the horizontal axis, we use square root of 3, either side of the center. So I was going to sketch it. I got to go -8, 7. I'll just eyeball it. All right, and then my vertical major axis means I have to go up 2 and down 2. So go 1, 2, down 1, 2. And then square root 3, what's that approximately? 1.7. So I go right 1.7 and left 1.7. And there's my ellipse. It's Thursday. So the Thursday quiz, quest, whatever. I put, I think, 3 questions on it. There's an eliminate the parameter. We just went over one of those, right? Use a Pythagorean identity. Eliminate the parameter, plus some other questions, like, and then what kind of conic section is it once you eliminate the parameter? There's a complete the square. To go to standard form. And then again, what type of conic is it, and graph it. This one I think I also asked you to graph. And then finally, I gave you a standard form. And I just asked you what type and graph it. So there's 3 questions dealing with the 3 different ways that I can give you an equation of a conic section. Parameterized, with where you have to complete the square to turn it into a standard form, and then just plain old standard form. And then with all of those, you should be able to answer the same kinds of questions. What type of a conic is this? Sketch its graph. Yep. Mm-hmm. Eliminate parameter question. So for eliminating the parameter, basically you pick one of the equations and solve for t. Like if x equals t plus 1, I would just solve this thing for t and say t is x minus 1. And then I would go to my y equation and substitute the t with an x minus 1. So this is actually a line, y equals 2x minus 2. Right? So that's the easiest kind. Just take your x equation, solve for t, plug it into the y equation. When you have sines and cosines, it's harder to solve for t, right? So I typically just say, well, I know that cosine squared plus sine squared is 1. I know this Pythagorean identity. And then I can replace the cosine in this equation. I can replace cosine with x and sine with y. So this says x squared plus y squared equals 1. I say, oh, that's a circle, right? It's centered at 0, 0 and radius 1. Yeah, absolutely. Oh, no, yeah, on a quiz, I would definitely not like surprise you with having to use a new identity to relate. Yep. So like in this one, I know same thing. I start with the fact that cosine squared plus sine squared equals 1. And then I'm going to solve. I say x is 5 cosine t. So it's kind of similar to the easy ones, but instead of solving for t, I'm just going to solve for cosine t. Right? Solve for cosine t, and I get x over 5. And then in the y, I solve for sine t, and I get y over 2. And then in your Pythagorean identity, you replace cosine with x over 5. So this is going to be x over 5 squared plus y over 2 squared equals 1. And you could leave it like that, or you could say x squared over 25 plus y squared over 4 equals 1. This is the best way to write it because now it's in the standard form of a conic section, and you could easily say, what is this? An ellipse. Yep.